Seen from Earth, it's instantly recognizable, a golden sphere wrapped in a ring of light, floating in silence. Elegant, balanced, the picture of order. Up close, none of that holds. Those rings aren't decoration, and they aren't permanent. What looks like a halo from here may be up close, the wreckage of something that used to be whole. This is Saturn, and that ring isn't a crown. It's a crime scene. Start with what the rings actually are, because the word rings undersells it completely. If you could fly into them, you wouldn't find a solid band of gold. You'd find a flat field of ice and rock, fragments ranging from grains of dust to chunks the size of a house, all orbiting in the same plane, all moving at tens of thousands of kilometers per hour, constantly colliding and breaking apart. The whole system stretches wider than the distance between Earth and the Moon. And yet, in most places, it's only about 10 meters thick. If Saturn were the size of a basketball, its rings would be thinner than a sheet of paper, a razor-thin field of ice, hundreds of thousands of kilometers wide. So where did all that ice come from? The leading explanation is violent. At some point, likely less than a few 100 million years ago, a moon, possibly one as large as some of Saturn's mid-sized moons today, crossed an invisible boundary around Saturn called the Roche limit. Past that point, a planet's gravity pulls harder on the near side of an object than the far side, hard enough to overcome whatever's holding that object together. The moon didn't crash into Saturn, it came apart in orbit. Saturn's gravity stretched it, then shredded it, then spread the pieces into the disk we see today. If that theory is right, every time you look at Saturn's rings, you're looking at a funeral that never ended. Now look at the planet itself, because Saturn has its own quiet violence, separate from the rings entirely. Saturn spins so fast, once every 10.5 hours, that the planet isn't actually a sphere. It bulges at the equator and flattens at the poles, like a ball of dough spinning on a fingertip. The difference is large enough to measure from Earth with a backyard telescope. And at the North Pole, there's something that shouldn't exist. A storm shaped like a hexagon. 6 straight sides, rotating as a single unit, wide enough that 4 Earths could fit inside it. Nature doesn't normally produce straight lines. Weather systems are circles, spirals, chaos. But this hexagon has been there since at least the 1980s, when Voyager first photographed it, and it's still there now. Lab experiments with rotating fluids can produce similar polygon shapes at small scale, but on Saturn, this isn't a tank of water. It's a storm system the width of a planet, locked into a shape our intuition says should not last, and it's been stable for decades. At the center of that hexagon sits a vortex, a storm within the storm, with winds far stronger than anything at its edges. It's been described as looking like a giant eye staring straight up that never closes. And roughly once every 30 years, Saturn does something even stranger. A storm erupts that's large enough to wrap around the entire planet. It's called the Great White Spot, and it doesn't happen gradually. Within weeks, a bright band of ammonia ice clouds dredged up from deep inside the planet spreads until it encircles Saturn completely. Some measurements suggest the lightning inside these storms can be thousands of times more powerful than lightning on Earth. For a planet that looks calm and golden from Earth, something the size of Earth's diameter is exploding upward from its interior every few decades. And we only fully understood this because spacecraft happened to be watching. Saturn has more than 140 known moons, but one of them might be the strangest object in the solar system that we've actually landed on. Titan is larger than the planet Mercury, and it's the only moon anywhere with a thick atmosphere, thick enough that the surface pressure is actually higher than Earth's. From orbit, Titan looks almost familiar. You can see what looks like coastlines, river channels, even what appear to be lakes. None of it is water. The temperature on Titan's surface is around minus 179 degrees Celsius. At that temperature, methane and ethane, gases on Earth, exist as liquids. Titan's rivers are liquid natural gas. Its lakes are liquid natural gas. When it rains on Titan, it rains the same substance you might use to heat a house, falling slowly through an atmosphere 4 times denser than ours. In 2005, a probe called Huygens, carried to Saturn by Cassini, separated and descended through Titan's atmosphere alone. It took over 2 hours to fall through orange haze so thick that sunlight barely penetrated, and it landed, not shattered, but intact, on a surface the consistency of damp sand. For about 90 minutes, it sent back images and data from the surface of a moon nearly 1 billion miles from Earth, before the cold silenced it for good. It remains the only successful landing ever made in the outer solar system. Then there's Enceladus, a moon so small it could fit inside the borders of a mid-sized country, and so bright it reflects almost all the sunlight that hits it. For decades, it looked like nothing more than a featureless ball of ice. Then Cassini flew past its south pole and found cracks in the ice, long parallel fractures nicknamed tiger stripes. And from those cracks, the moon was venting. Plumes of water vapor and ice particles shooting hundreds of kilometers into space, fast enough to escape the moon's gravity entirely. Beneath that ice shell, there's a global ocean of liquid water, kept warm not by sunlight, which barely reaches this far out, but by a similar kind of tidal flexing to the one that powers Io's volcanoes near Jupiter. Saturn's gravity squeezes Enceladus on every orbit, and that squeezing generates heat. That ocean contains salt. It contains organic molecules. Cassini flew directly through one of these plumes and tasted it with its instruments. In a sense, we have already sampled the inside of an alien ocean. We just don't yet know if anything is swimming in it. All of this, the rings, the Hexagon, Titan, Enceladus, came from one spacecraft. Cassini arrived at Saturn in 2004 and spent 13 years in orbit, far longer than its planners ever expected it to survive. By 2017, it was running out of fuel. An uncontrolled spacecraft, drifting near moons like Enceladus, risked eventually crashing into one and contaminating it with bacteria from Earth, compromising any future search for life there. So NASA made a deliberate choice. They aimed Cassini at Saturn itself and let it fall. On its final orbit, Cassini dove into Saturn's atmosphere, transmitting data the entire way down. It had no heat shield, nothing built to survive entry. Within about 2 minutes, the heat and pressure overwhelmed it, and the signal stopped. 13 years of data, ending in a dive that was planned down to the final second. And here's the part that makes all of this feel temporary. The rings, this entire structure, are dying. Saturn's gravity is slowly pulling ring material down into the planet's atmosphere as a kind of icy rain, a process that's actually been measured by Cassini. At the current rate, estimates suggest the rings could be gone in a few 100 million years. On cosmic timescales, that's soon. Saturn has existed for 4.5 billion years. For most of that time, it may not have had rings like this at all, and for most of its future, it won't either. We happen to be looking at Saturn during the brief window when it has them. So the next time you see Saturn through a telescope, remember that bright ring isn't a permanent feature of the planet. It's a temporary structure built from the remains of something that broke apart, slowly raining back down in a system that's been quietly destroying itself this entire time. Sometimes what looks eternal is just something falling apart slowly enough that we mistook it for permanent. And if you want to see more of what's hiding behind the calm, subscribe, because the solar system has a lot more of this to show you.